we have now talked about element effects, inductive effects, and resonance effects that all impact acidity. The last factor is hybridization of the atoms involved. And when we think about unhybridized orbitals here, we usually have an s orbital that's lowest in energy. It's spherical. It's closest to the nucleus. And then we have three p orbitals that are the px, py, pz, so the orbitals on different axes. As far as hybridizing those orbitals, if we hybridize to sp orbitals, we have two hybrid orbitals. Each of those hybrid orbitals would be one part s, one part p. Because of that, since they're 50% s, they're actually going to be relatively low in energy. So that the higher percent s, it's going to be lower in energy because s orbitals already start out at the lowest energy level. And we would have two p orbitals left over. So if we compare sp orbitals to sp3 orbitals, sp3 orbitals are going to be at a higher energy level because they're each only 25% s character. Okay, so how does that impact acidity? Why is that important? So here we have three different hydrocarbons. This is an sp3 hybridized carbon, sp2 hybridized carbon, and an sp hybridized carbon. And all of those can lose a proton. So if we lose a proton, we're going to have a lone pair on that hydrocarbon. It's going to be in an sp3 orbital. We would have a lone pair on this hydrocarbon that would be in, so this is in an sp3 orbital, this would be in an sp2 orbital, and if we have a base that removes the proton from this alkyne, we would have the lone pair and the negative charge in an sp orbital. So which of these is most stable? Again, when we're trying to relate, or when we're trying to understand how acidic something is, we have to think about the stability of the conjugate base. And here we have three conjugate bases. All of the negative charges are on a carbon atom, but they're in different orbitals. This one is in an sp orbital. Sp orbital is lowest in energy. So an sp orbital is lowest in energy, therefore this conjugate base is the most stable. This conjugate base equals most stable. On the other hand, an sp3 orbital would be the highest in energy. It's the lowest percent s, so this is highest in energy. And that would make it the least stable. So as far as acidity goes, since this is the most stable, it's going to be the most acidic, because this is the least stable conjugate base. This is going to be the least acidic. Okay, so what does that look like in numbers? If this is the most acidic, what is its pK? The pK value of an alkyne is 25. That's one of them that you've all learned on that figure that we've talked about. The pK of an alkane that's sp3 hybridized is about 50. So you can see that hybridization has an enormous impact on acidity, and that all has to do with the percent s character of the orbital. So higher percent s character of the orbital, more acidic. Lower percent s character in this carbon-hydrogen orbital, less acidic. That's how we relate acidity and the energy of the conjugate base. That's how we relate the stability of the conjugate base, thinking about the orbitals that they would be in, to the acidity of these different hybrid orbitals. And that's the last factor involved in evaluating acidity of different acids. So that's great.